Picking up where we left off yesterday in lesson 1.6. So we are working with all these different transformations. We'd worked a lot with translations on the front. We'd done a little bit with reflections. And now we're working with our stretches and shrinks, or stretches and compressions if you prefer. We had looked at A, which was just multiplied by a number. And when the whole thing is whole expression is multiplied by a number, that's a vertical stretch or compression, depending on the number. B, we've looked at two different ways. Because there are the parentheses, we looked at two different ways. First of all, we looked at, if you multiplied it out, you got 0.16x squared, the fact that that's a number times the expression. So that was our vertical. But then we also looked at, since it's a number times x inside the squared, how we can make that x divided by a number. And in turn, talk about the horizontal factor. So, let's look at C. I'm going to zoom this in some, in hopes to give you a little bit more zoom. What are your thoughts on C? It's kind of like B. I agree.
Yeah, because it's greater than 1. So
okay, so number's greater than 1. Okay, so with it being the same type of problem as B, I want to talk about the horizontal and the vertical options. Which one would you prefer to do first?
Vertical.
Okay, the easy one is the vertical. What do you know about 5x quantity squared? Okay, that becomes 25x squared. And so what do you know about 25x squared in comparison to just x squared? We're multiplying by factor of 25. So this is vertical stretch. By factor 25. Are we okay with the vertical option there? Okay. I do want to talk about the horizontal option also. 5x quantity squared. Okay. How do we think for horizontal?
We have to put x over c.
Okay. So x over c, fraction. In other words, I want to know, instead of this being 5 times x, this is x divided by what? Not x divided by 5. X divided by 1/5. Because if you recall from over here, it was 2x times 2/5. X times 2/5 is the same thing as dividing by the reciprocal. So what is the reciprocal of 5? 1/5. So I can rewrite this, instead of 5 times x, as x divided by 1/5, still quantity squared. If we look at that, x divided by 1/5, I've got x divided by a number, so that takes us into the horizontal ballpark. Horizontal what? Shrink by a factor of 1/5. Because it's smaller than 1, yes. So horizontal shrink by a factor of 1/5. Okay. And again, makes sense, right? Vertical stretch means you're pulling something taller. And so as you pull something taller, ideally it's going to shrink it horizontally because it's going to become skinnier. Okay, last one in this section. What are your thoughts about D? Y equals 1/3 x squared. What'd you say? Okay. Yeah. It's already 1/3 times x squared, right? So I can't, unless I'm going to redo that and take the square root of it and put it within parentheses, which is not, we're not going to go that difficult route. Just look at it. It's 1/3 times x squared. So multiplying by number is vertical, stretch or shrink. Because it's 1/3, we're going to say shrink. So I agree. Let's call this a vertical shrink. And this is by a factor of 1/3. It's just the ones where it was parentheses, like a quantity squared, that I was going to talk horizontal there.
So vertically, you don't have to ever really do a home
Yeah. And that's why, think about it. Which one did we see last year in Algebra 2? We saw the vertical, right? And so obviously that kind of backs up the fact that horizontal is a little tougher, right? And because we're just now adding it in this year. Yes?
So could we do the horizontal?
We could do the horizontal, yeah.
So it would be a horizontal stretch, but how could you figure out like the factor of this thing?
Well, we'd have to back up a step and make it so it's like something squared. So you'd have to do the square root of 1/3, and then it'd be the reciprocal of the square root of 1/3, which would be the square root of 3/1, or no, it's just a square root of 3. So this would be a horizontal stretch by square root of 3. If you followed that, great. If not, don't stress about it. Okay. Does that make sense though for your question?
So once you take the square root, you can then put it in parentheses and the square again.
Mm-hmm.
That's how you would get how you wrote before.
Yeah, because if we wanted to back this up and write it so it's something squared, then you do the square root of, basically, 1 is 1. But the square root of 3 is what the important part is. Because then when you square the square root of 3, it takes you back to 3. Okay. Moving on. Let's look at example 5. This is writing more equations. We are being given the function f of x equals x cubed minus 16x. So that is your base, so to speak. Find the equations for the following non-rigid transformations of f of x. So, based on the fact that f of x is given as x cubed minus 16x. Like, that's your given factor there, or your given function. How do we affect it with a vertical stretch by a factor of 3? What do we have to do there, Ross?
Wouldn't you put x cubed minus 16x in parentheses without plus?
Okay, so in order to do a vertical stretch, if you looked on the previous page, it's the idea of 3 times f of x, right? Which means we're doing 3 times the entire function. So 3 times x cubed minus 16x. Could we multiply that out? Sure, let's do that. So if I multiply this out, 3 f of x is equivalent to what?
3x cubed.
48x. Yep, 3x cubed minus 48x. And that's all you can do in that particular problem. If it had been a vertical stretch by a factor of 3, then we would have to go into those x's and do x divided by 3. Okay? But this was just vertical, so the vertical rule on the previous side said c times f of x, right? So that's what we did. Okay. Horizontal shrink by a factor of 1/2. So how do I do a horizontal shrink? Instead of just f of x, what are we going to have to do?
I'm not sure about that, but could we take an alternate route and do a horizontal stretch? That's the class burgers do.
It wouldn't be. It wouldn't be a. So if you're trying, you mean vertical stretch, but you'd more be, since we're going from horizontal to vertical, you'd more be squaring it. But does that work? That doesn't exactly match up. We'd have to think about it a little bit more. I don't know. Let me show you what this comes out to be, and then you can analyze versus the final answer. Because I'm not sure. I feel like it should work, but it's not clicking with me. So, okay. So, it's x divided by c according to our front page, yes? What is our c value? 1/2. So that means I'm going to write it as f of x divided by 1/2. Now, I don't know about you guys, but I don't really want to, every place I see an x, put in x divided by 1/2. So here's what I would ask you to kind of side note and think. What is x divided by 1/2 in a different form?
Or no, it would be like
Yeah. Division by a fraction is multiplying by the reciprocal. So x divided by 1/2 is x times 2/1. Multiply by the reciprocal to divide fractions. And so, yes, that does become 2x. So what we can really do is f of 2x. Now, the idea of f of 2x. Every place you see an x, replace it with 2x. So my original function is x cubed. So instead of x to the third, we're going to say 2x quantity to the third. Instead of minus 16 times x, it's going to be minus 16 times 2x. So now, if we clean this up, 2x to the third. 8x to the third minus 16 times 2x minus 32x. And that's as far as I can go. They're not like terms, so I can't go any farther. I'd have to sit down and look at that because I can't get the vertical to work. At least not in my brain without writing it out and figuring out where my mistake is. So.
Well, my thought process is by multiplying it by the reciprocal, you are getting to it.
But then I feel like you'd have to square it. No, you'd have to cube it in this case. That's the difference I was leaving off. Because this problem has the cube in it, you'd have to cube that part. So, I don't know. It gets a little more complicated. So, I'm moving on for the moment. We can look at that after the fact if you really want to. Okay, example 6. Combining transformations in order. So, the graph of y equals x squared undergoes the following transformations. Notice what it says. In order. Find the equation of the graph that results. So based on the fact that I'm starting with y equals x squared. My recommendation is I'm going to go step by step with you. Some of you may be able to just see it and write it all out at the end. That's fine. I'm going step by step. So, y equals x squared. What does that become if I adjust it to have a horizontal shift 2 units to the right. Okay. 2 units to the right. You take the 2, the opposite, and it's with the x, opposite sign, yes?
Yep.
So that means we're going to subtract 2 from the x, which means you are in parentheses. We talked about this yesterday, right? Does that seem familiar from yesterday?
Oh, yeah,
Some of you weren't crazy about it yesterday with me, but dang it, I wrote it wrong again. So that squared needs to move outside the parentheses. Now, take that equation and adjust for the next part. A vertical stretch by a factor of 3. So, vertical stretch by a factor of 3 means you're multiplying by 3. So this becomes y equals 3 times x minus 2 squared, quantity squared. And then, a vertical translation 5 units up. How do we go 5 up? You add 5 on the outside at the end. So, 3 times x minus 2 quantity squared up 5. That is the equation that represents those in order.
So the first two are just the thought process to get to the present.
Yeah. I was just kind of writing it step by step so you can see, okay, this is the first step, this is what this step is, putting it all together. As I said, some of you just jumped right to the final equation. Your choice. Now, part B here. Apply the transformations in opposite order. And let's see how things change up here. So if I do this in opposite order, keep in mind we are starting with y equals x squared. What's the first thing I'm going to do to that y equals x squared? Okay, vertical translation 5 up means we're going to say plus 5. Then what? Okay. Vertical stretch by a factor of 3 means you do what with that 3? Okay. And I'm not actually going to distribute it, but it multiplies by the whole equation. So I'm going to write it as 3 times x squared plus 5. Does that right there make a slight difference on our equation?
Yeah.
And it does.
That's what that 2 squared up.
Okay. And then what's the last thing we're adding? We're going 2 to the right. So where am I putting that? Okay, it's going to be in with the x, so we're going to have parentheses around the x. So it's still 3 times everything. But now my x squared becomes x minus 2 quantity squared. Then there's the plus 5. And then there's my other parentheses, which I turned into brackets, because I tend to use brackets for the outside ones.
Yeah.
And I have it looking like this when we reverse those steps. Does that change things just slightly? It does, doesn't it? What? You could, but I'm just leaving it like this. Okay?
I was going through the first one. I was thinking about that. I just kind of thought that we needed to do the vertical stretch by 3. I could just have everything on the way.
Yeah, and the difference is, when you do a vertical stretch by 3, you're taking the vertical unit, which is the y unit, and multiplying it by 3. Okay? If you, in this one, if you've already translated your coordinates 5 up, and then on top of it you're doing a stretch of 3, those numbers are getting that much bigger. And so that's where it does make the difference. Okay, one last thing, and then I'm hoping you guys can have a little bit of work time here. Transforming a graph geometrically. So there is a graph there. Not a very good one, but there's a graph there. And the graph of y equals f of x is shown. So right over here, this is y equals f of x. Determine the graph of the function 2f of x plus 1 minus 3 by showing the effect of a sequence of transformations on the graph y equals f of x. So, thoughts on which transformation we could start with. And keep in mind, there are certain things that have to come after certain things or whatever before certain things. But also on the flip side, there are a couple different ways you can get to the same answer here. So, Levi?
We start by going left to one.
Can you start by what?
Going left to one.
You can. Okay. You can start by going left 1. Or what's the other option of what I could go ahead and do here? What? The down 3 is actually going to have to be the last thing I do. Because I've got to do what is directly on the x first, which means the left 1 I could do. Or if you wanted to, you could actually do the vertical stretch first and then the left 1. Like those two are kind of interchangeable. Yeah. On the down 3, so I guess I kind of just told you. I assume you realize there's that vertical stretch, the left 1, and the down 3. I assumed we could identify those. I hope I'm not assuming too much there. Okay? Now, the things done to the x, the vertical stretch, the left 1, need to be done first. Save the down 3 for last, because once you move those y values, that totally changes what your vertical stretch is. Okay? So, which one do you guys want to do the left 1 first? Okay. So if we do, and I'm just going to kind of put over here, that we're doing that x plus 1 there. So we are doing the left 1. Now, based on the fact that what? We had points at, I'm going to go with 4, 0, 0, 2, whoops, and negative 2, 0. What do I have to do with each of those points?
Move left 1.
Move them left 1. So now we're going to be at 3, 0. Instead of 0, 2, where are we at? Negative 1, 2. Instead of negative 2, 0, 3, 0. Now, when I draw this, I kind of draw a curve on that part and then more of a straight line there. It's really more about the points, right? It's about getting those points. Since we did left 1 first, what must I do next? We must stretch it. Those two are interchangeable, but they have to be the first two done. So this is a vertical stretch by a factor of 2. Again, I'm going to now, vertical. Vertical is up and down. Which coordinate represents up and down? The y coordinate. So if I'm vertically stretching something by 2, I'm taking every y value and multiplying it by 2. What about my x value? Stays as is. That would be if we are horizontally affecting. But vertically, we're going to just affect that. So, this point that is at 3, 0. What happens when we vertically stretch that?
0 times 3, so 0.
It's 0 times 2 technically, and 0 times 2 is still going to be 0. So you still have a point at 3, 0.
Oh, wait, so, you go with the original one? Because you said 5 2. Is that right?
The stretch is by 2. The ordered pair is 3, 0. But the stretch is by 2, so we'd be multiplying by 2, not 3. You said 0 times 3.
Oh, then, yeah, I meant 2.
Which is what I figured, so. Okay, now, this point was at 0, 2. Now it's at negative 1, 2. What happens when you stretch vertically the negative 1, 2? What is it that I'm stretching? The 2. And what am I multiplying by? 2. 2 times 2 is 4. So negative 1, 2 becomes negative 1, 4. I'm just vertical stretch here. And then our other point is negative 3, 0. What happens when we vertically stretch that? What is our y value? 0. And so when you multiply 0 by 2, still 0. The point is, anything on the x-axis, when you stretch it vertically, goes nowhere. And so those are my new points.
So, could we technically write, like, y times 2?
Yes, that is exactly, because f of x is another name for y. So we did y times 2. Then what's the last thing we need to do? The f of x minus 3 part, which is down 3. So each of those ordered pairs, or each of those coordinates goes down 3. The left or right and the horizontal stretch or shrink affect each other, yeah. Okay, so I did have a point here at 3, 0. When I move 3, 0 down 3, we're going to be at 3, negative 3. I did have a point at negative 1, 4. When I move that down 3, negative 1, 1. I did have a point at negative 3, 0. When I move that down 3, negative 3, negative 3. Okay, your homework, if you haven't already written it down, is on page 136. 2 through 32 evens. You've got 10 minutes. I would ask that you make the best out of it.